Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over the frequently asked questions on this paper folding paper assignment. And so, you basically have this question you're asked about folding paper until it reaches the moon. And let's see. The first thing to understand is that starting with 0.1 millimeters, it's gonna double each time. Every time you fold it in half, it's gonna just fold on top of itself, which is doubling. Now this process of doubling times 2 is gonna be giving us an exponential function, because that's the pattern of exponential functions. So you're gonna basically have this equation y equals and exponential functions have these two letters here, where this is the starting initial value and this is the growth factor, the multiplier. So this is the starting value. You could also think of it as the y-intercept. And this one over here, the b, is your base, or it could be your multiplier. Okay, so our starting value is going to be 0.1. So we see that 0.1 is our starting value, and our multiplier is going to be times 2. So that's going to be our multiplier. So let's go ahead and replace each of these letters. So there's going to be 0.1, and then this will be 2 because it's doubling. And so if you're explaining the meaning of each of these y, 0.1, 2, and x, if you're explaining each of these components in terms of the physical meaning, that's going to be, so we already said that this was the thickness of one paper. And then this one was the thickness doubles with each fold. And then this is going to be, what is this, the number of folds. And then this y would be the total thickness of the paper. Okay. So yeah, we got to get to what, 384,400 kilometers. Okay, so that means that is going to be the total thickness of the folded paper. Needs to be that amount. So if we go back, that's going to be here, right? This is going to be the value that you plug in, the 384,400 kilometers. However, this equation, this 0.1 is millimeters, so we can't really just plug this kilometers into an equation that uses millimeters. So we need to convert this from kilometers to millimeters. But there's going to be a step here. We can't go straight from kilometers to millimeters. We got to go from kilometers to meters, and then meters to millimeters. So that's the first one, kilometers to meters, and then meters to millimeters. Okay, so we're going to get into converting here, units of measurement. And so we got to state the facts of the kilometer and meter. So how many kilometers are in a meter, or how many meters are in a kilometer? Kilometer is greater than meter. Kilo means 1,000, so it's 1,000 of these smaller units to get to 1 kilometer. So I'm going to write that down. 1 kilometer is going to be 1,000 meters. Okay, so what about for meters and millimeters? Well, I know there's, with centimeters, there's 100 centimeters for 1 meter. Centi means 1. Milli means another is 1,000. So 1,000 millimeters to get to, because millimeters are very small. So 1 meter is going to be 1,000 millimeters. Okay, now with each of these, with each of these facts, there's two fractions that you can use. You can either put 1 kilometer over 1,000 meters, or you can use 1,000 meters over 1 kilometer. And the same thing for this other one, but let's get to this after, because we got to go from kilometers to meters, so we're going to do this first. Okay, so to convert, so we're going to basically convert units of measurement okay, so you're going to need to cancel out the kilometers. Okay, this kilometers needs to cancel out, and in order to do that, we're going to multiply it by some fraction such that the kilometers cancels out. So if we use this fraction, the meters is on the bottom, the kilometers is on the top of the fraction. Well, this kilometers won't cancel out because this technically is on the top of a fraction, right? You could put it over 1. So we need the kilometers on this one to be in the denominator, so that way the numerator and denominator could cross cancel the kilometers. So that's why we're going to use this one. So this is going to be 1,000 meters over 1 kilometer. And from that, you can cross out the kilometers. And now we're left with meters. So that's how we go from kilometers to meters, is using this one of these two, but in this case we use the kilometers on the bottom so that they could cancel out. And so now we look at now we're on the next step, when we're looking at this other fact of the 1 meter is 1,000 millimeters. So we could do 1 meter over 1,000 millimeters, or we can do 1,000 millimeters over 1 meter. And again, the decision that we make has to be such that the meters cancels out on the top. This meters is on the top, so we need the meters on the bottom. This one has millimeters on the bottom, so we're going to use that one over there. This one would allow us to cross cancel out the meters. Okay, so in this case, the meters cancels out, and now we're left with what we wanted. We have our final, millimeters here, right? So we went from kilometers to meters here, and then meters to millimeters now. And so now the only thing we have to do is multiply each of these, values here. So that times 1,000 times another 1,000. So that's going to be, let's see. And anytime you multiply by 1,000, one with a bunch of zeros, you just count the zeros and add them to that. So we're going to have 384,400 with 6 zeros. Okay, did I do that right? So, 400. 384,400. Okay, so I had to wait to, okay, hold up. So that's our original value times 1,000. I'm going to add 3 zeros times another 1,000. I'm going to add 3 more zeros. So that looks better. Okay, so it's this many millimeters to the moon. Okay, so we want to find this value. We want to find this value here for y with this equation. Okay, so in order to do that, we're going to need to use some technology here, because we don't have a method of solving for this quite yet algebraically, which would be a lot easier, but we're just going to do this through guessing and checking. So I'm going to turn this into a table, and I'm going to look for the y value, right? X is how many folds. Y is the the thickness of the paper, I'm looking for, okay, so now this is scientific notation. What does this look like in scientific notation so we can understand if we're looking at it on the graph? Well, scientific notation says that we need the decimal here. It's always at the end, so we count how many times you have to move it to get to where we want it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we moved 11 spaces to the left. So in scientific notation, you're going to take the decimal without any zeros. So we're going to drop the rest of these zeros. We're just going to, so we want the decimal after the first number with the other numbers times 10 to the, and it took 11 spaces. So that's going to be a positive 11. If this were a really small number like 0.0000384, that would be a negative exponent. But because this is a large number, this is a positive exponent. So we're looking for about 3.84 to the times 10 to the 11th in scientific notation. So we're at 10 to the 7th, so not quite yet. 10 to the 8th, 10 to the 9th, 10th, 11th. Okay, so we're pretty much at the place where we are looking for 3.84 times 10 to the 11th, which is right between these two. If it was this one, that would be too small. It wouldn't get us quite to the moon. This one would be a little bit past the moon, but of course the distance between the Earth and the moon varies. So I'm just going to go with 42, okay? 42 folds. So so that would be 42 folds here. A lot of work, right, to get that one. But I hope I helped you out.